Okay,
Live.
we're live. Hello, Russ.
Good morning.
Good morning. Great to meet you again.
Absolutely.
Okay, well, we're going to be talking quite a few questions about microservices and what is happening around one of the hottest buzzword in software development in the last 2 years. Actually, it was something interesting happening. That was summarized by a tweet from Martin Fowler, actually retweeting Stephen O'Grady, about the difference between SOA that was mostly led by vendors and what is happening with microservices, which is currently led by developers and apparently performing a little better. Maybe it's too early to say that. What is your take on this?
I think Martin has a very valid point. I think there's danger, though, in what we are doing right now. So no one wants another vendor-driven effort to do services. I think we've been down that path, and most people realize the value wasn't necessarily delivered. With microservices, the bottom line problem is that there's little guidance for developers about what a microservice could or should be. And there's danger in the term itself, because in the nature of the beast, you think size. The moment you do micro anything, you naturally assume that size is an incredibly important part. And it's not really, in my experience, the most important part by quite a long stretch. And I've encountered enough systems now where people have simply broken things into small things for very little reason. And they've ended up with many of the same problems they had before. If not, those problems have often been amplified by the fact they now have a lot of small things to look after. And so I know there's a lot of efforts in this area about trying to gradually build a theory about how you get to microservices. And that's kind of what we cover in the course, as well as how to do microservices themselves and what they should look like, how they should be broken into pieces, and when not to as well. So like a lot of these things, you need to understand the value you're aiming for. What is the system supposed to be able to do that it couldn't do before? And once you have that framed, then a microservice-based approach takes on a new meaning. It's a set of design decisions to end up with pieces that meet the need that you're looking for. None of that's a very broad statement, but I'll give you an example. If you found in the past that it was very, very difficult to maintain your monolith, if you found it at some point in time, you inevitably got to the point where you would say, let's do this again. You'll get it right next time. Then you've kind of, that is one of the potentials that microservices can give you. By having the right smaller parts for your context, you might be able to achieve a system that can evolve as quick as it needs to meet the needs of the business now and potentially in the future as well. So that's one of the values you can aim for. Another value you can aim for is scalability. And these are not mutually exclusive. So you may decide that parts of the system need to be scaled quite differently than other parts of the system. And the aim with microservices there is you'll end up with a set of microservices that support that scaling characteristic. The interesting thing, I suppose, and perhaps the difference with what I tend to teach, is that I start by not making decisions on structure early. I very much emphasize the idea of coming up with events, seeing events as a key abstraction across a system anyway, and that then can be implemented in a number of different ways. Once you start with the events, you're not encouraged to go for the parts too early and to go for the structure too early, because structure, the phrase I use in the course is structure has an ossification effect. It tends to crystallize the system and make decisions harder in places early. And so what you do is you try to keep things as fluid as possible, using events as a key abstraction for discussion first, and then gradually working towards the structure that supports that. And there's nothing to stop you implementing these things in any of the practices that people are familiar with, like HTTP. I'm always hesitant to say REST, because a lot of the services I've seen are not really RESTful in any true sense. They're pretty much HTTP with something being thrown across, which is fine. If it works, it's absolutely okay. But what we do then on the course is when we get further, we get into the practicalities of how you make those decisions about what different integration styles to use and everything else. But it's all framed by the fact that you are trying to decide what value, what you want from the system. Is there something you need to do from the system you couldn't do before? Otherwise, frankly, a monolith might be the right answer.
Yeah. Well, talking about the monolith and the way you were describing it, I would say when they said like, oh, this time we got to do it again. And then the feeling is, when was exactly the point where we turn left where we should have turned right? It looked manageable at a given moment, and then it kind of exploded, and you roll back. You want to trace back back to the original scene, and I have the feeling that the original scene is a lot deeper. Is looking data first. Is looking about information silos, and I need to access this data type of approach. And it's not surprising.
Yeah,
I like this orange little thing in my back, and the events and discovering a system in that way, and makes a lot more natural discovery. And I actually also agree with the tricky thing about the microservices naming. I've met a lot of companies that basically, well, they had initiatives where they wanted to be compliant with the idea of microservices, regardless of the business goal. There's a lot of ambiguity in that area.
The question then is why? You know, there has to. It's similar. Let's be honest. It's similar across a lot of our industry. A lot of endeavors in our industry are done because somebody says do X, and you think, well, they're smart people. Let's do that. And these are good intentions, right? And we do want simple answers to complex problems half the time. The difficulty is that with microservices, it's such a broad term, really, and it doesn't really manifest the value that it represents either. That it's so easy to do it wrong. It's as simple as that. It is very easy to build a system, as you say, where in retrospect you look back and say, we've done it again. And then when you look back in retrospect, you're looking for that moment where you made a wrong decision, or where there was a design decision you could have done better. And in fact, one of the things I talk about on the course is it's rarely one decision. It's actually usually a set of assumptions that has been ingrained in your work, probably throughout the entire project. There is a set of baseline assumptions that we, as software developers, we bought into. I think these things even get taught in college. You know, we assume we know what we're doing. We don't. We assume the business knows what it wants. They don't. When you combine those two things, you build systems differently when you have those two assumptions that you're working with.
Yeah, totally makes sense. And well, talking about our incoming training class, can you tell us something more about it? Like, your goals, your path, the technologies we will be using.
Absolutely. So, in broad strokes, the first period of the course is about challenging some of those assumptions. So it's quite design centric. You could even say architecturally centric. And what I do is ask everyone to bring their own systems, their own architecture, something they've worked on recently, and use that as the context. So I don't like to work with a canned example, because canned examples are canned. and they're not what people are going to work. It's very rare that I find someone that's going to work on a banking system that is quite as trivial as the one that I could possibly deliver. So I ask them to bring their own complex context, and then we work through that. We practice all the design approaches I've just mentioned. And then after that, we start to explore implementing parts of it. So I call it the second phase is we're actually trying to stand the castle up. So we start to build parts of the castle that are now rationalized as the basis from the base of those decisions made earlier. So we have a different set of decisions that lead to a different set of pieces. And they can be implemented in any language that you'd like. I haven't encountered yet a particular attendee that's brought a language that I haven't touched on at some point. Okay. I'm unlikely to critique their usage of, say, Python, but I might critique the implementation breakdown of what they have, and does it, effectively express what we've talked about. So that's usually quite fun because people can use any technologies they want to. It can be the technology they use at work, it can be the technology they would like to use at work, anything they want to bring to the game. Once we've done that, the third phase is an interesting one. I in some respects, I'd prefer the third phase to be first, but it seems to be easier to teach in this order. The third phase I call the stressor phase. So what we're doing there is, one of the key differences with a microservice-based system is the constraints and stresses under which it can perform. So when you look at change and you look at scalability, which is just another form of change or reacting to change in some respects, you could just try and put a system together and hope that it meets those stresses. Well, one of the things that's I think quite innovative in the industry at the moment is that we are learning that adding stress into the system can improve it. So one of the things we look at in the very last period is we'll look at implementing some of those stresses. So everyone's heard of things like Chaos Monkey, Simian Army, those sort of things, but very few people seem to understand why those things exist. They don't exist because people like to hurt systems. They exist primarily to help certain things become unignorable. So you cannot ignore the stress of systems going down. You cannot ignore the stress of networks going down. You cannot ignore these other stresses. And the trick with software developers is we're quite optimistic. We do like to think we can ignore some of these things. Yeah, if the network works today, we assume it will probably work tomorrow. Whereas some of the assumptions we challenge at the beginning of the course are then held out through the final phase to say, no, we certainly can't assume some of those things because we're actually going to be the cause of our own demise there. And that's a good thing because that makes us need these other patterns. So we then talk about things like circuit breakers and bulkheads and how to implement those as well. There's always time to look at implementing some of those as well. But one of the key messages is that don't try and avoid stress. You want to try and create it because it will improve the design.
Yep. No, it's totally different feeling as a developer when you have a software component that you basically try to smash and it feels resilient. It just feels totally different. You can go home in the weekend without worrying for receiving a phone call, an SMS failure condition. Yes, unless it's something really, really big, you're safe. Then, in my experience, when you are feeling that safe, interesting things start to happen. You're not thinking defensively. You're thinking like, how could we improve the system? What else can we do to that? What else could we add business-wise? Or there's an opportunity over there. Let's stop playing in defense for the rain to fall and start, catching up opportunities. That's something more. It's actually weird to say it at the psychological level in the team.
Absolutely. I mean, this is what. This is, I think, the major learning from Netflix. Now, don't get me wrong. I think a lot of people copying Netflix is a bad idea because you're not Netflix. Chances are your organization, your culture, your context is not what they have. And so copying their practices or even copying just the espoused practices is probably not going to deliver what you want. However, there is a general principle that they've applied, which I think they've shown as to be very useful, which is this idea of not avoiding stress in the system. So they have a system that can handle change quickly. It's a system that's been delivered for two main stresses: one working on the public cloud, and another working on constant change, being the main innovative difference that they have. Now, when you couple those two things together, smaller pieces that can evolve independently of one another is extremely important. And because you don't want whole parts of the system failing because they've been grouped together. So you can see there, it's almost that microservices was an emergent pattern from those stresses. It wasn't something where someone says, we're going to do microservices and then, oh, we can handle some stresses. It was very much stress driven. And one of the things that I think is profound about what they've done, and which again, I find people don't necessarily realize, is that whenever they encounter a new stress, they create it. They go and create it. So when I think Amazon had a whole region went down, which was something that supposedly could not happen, which is always a phrase I love to hear. The first thing that Netflix did, I guess, after standing the system back up, was to create that problem again. So they now have their chaos gorilla. That's the point, is when you encounter these new stresses, because you can't deal with all stresses. You can't, in fact, you never should try to build a system that can handle all stresses. It will cost you too much money. It's you know, if you look at site reliability engineering, it's very much stresses the fact that if you try to cope with everything, then you end up with a system that cannot change for a start, because change is part of the problem. So what you do though is when you learn of a new stress, then you look to create it, because then you know there is progress. It's very TDD actually when you think about it, but it's TDD at the design level and the practices level, and there are a lot of outcomes. I mean, so one of the stresses I talk about on the course is the stress of you write it, you run it, which I think is one of the best stresses to really inform the concept of DevOps anyway. So yeah, the fact is, if you write some code, then you will have to be looking after it in production. That changed everything when it came to how people picked up new practices, what they did, how they worked together. Pair programming in a lot of organizations is still to this day a challenge. When you say to people, if you write some code, you have to run it, and if you want to go on vacation, then you're going to really need someone else to understand it too. Pair programming almost becomes a no-brainer. Let's do this, because I really want to go on holiday. And it's not just that brutal either. It's very subtle, that stressor, and it works in so many different socio-technical ways that that's a fascinating part of the course, as well as when we talk about culturally what microservices means, because it's in some respects it's a context and cultural pattern. It can change the way people work together, and it can be very accommodating to people working in lots of different ways. And if applied in its fullest, then you can end up with some of these practices that we've just discussed, things like pair programming that you wouldn't have naturally assumed would be anything to do with microservices. Well, if something is small enough that it can be written and run by a person, then you start to go, well, okay, now there's individual responsibility. That individual responsibility needs to become a team responsibility in some way. And what are the mechanisms for that? One of them is to pair. And that's just something that you notice. And it's in the more mature organizations that we're starting to see people getting that and going, okay, oh yeah, now I've got the small pieces. I can apply these further stresses, these sort of second line stresses. And that improves things as well. Yeah, there's a whole collection of things that we go into around that that you wouldn't normally associate with microservices. I mean, we go into continuous delivery and the challenges of continuous delivery with microservices and how to approach that. We talk about patterns such as CQRS, where naturally people misunderstand those patterns. I found people see the headline of separating commands and queries and their processing in the system. But unless you've got the stressors on the system, you don't necessarily see the need. And it's a nice framing argument, and it permeates the whole course. This idea that stress is part of our natural condition. I use a joke phrase. I say, production hates you. What are you going to do about that? Your code is about to go in an extremely hostile environment. What should we do about that?
That's a good one. That's a good one. I think we're probably gonna steal it and use it as a punchline for some tweet messages. The
whole line is production hates you, the networks hate you, and your users really hate you. No, everyone is out to destroy what you've got. It's sort of the way I think about it. In fact, actually, there's a little story I tell. Because I'm a motorcyclist, I ride a beautiful large Harley Davidson that I'm very proud of. And one of the things you're taught when you're a motorcyclist in England anyway, is that you have to think differently than a car driver. A car driver thinks that no one can see them. Okay, when you're driving, you're taught that to drive defensively, drive well, you assume no one can see you. Whereas on a motorcycle, you're taught, yes, they can see you and they want you dead. Everyone out there is actually a psychopath trying to get you out of the system. And that's one way of looking at your software hitting production. Yep,
a little bit paranoid or a pessimist. But,
it's not paranoid if it's true. It's due care. Exactly.
That is actually awesome. Yeah. I would say if there's anything else you would like to add, I'm actually okay with my questions. Anything else that you would say to potential participants or students for this class?
Yeah, I probably have one very frequently asked question, which is, I've had people say, I'm not overly technical. I'm running a team, or I've got, maybe I'm even what I would notionally consider to be part of the business. And should I come on the course? And I usually say yes, not because I need more and more people on the course, but simply because I think a lot of this starts there anyway. Everything that is taught on the course can be absorbed by someone who isn't day-to-day writing code. So I've carefully designed it such that there's enough profound thinking and there's enough change and direction that can be given to leaders, whether they're strongly technical or not, that unless, even if you're a CEO of a business, I said to people, if you're the CEO, that understanding things like stressors could change the way your organization works. And so, yeah, there's plenty to be taken away, even if you're not day-to-day hands on the keyboard. Now, there will be sessions where I say, we're going to write some code now, and you're going to do it, and I'm going to do it, and I'm going to show you what I've got. During those sessions, generally what I do is those more non-technical people, I'll take aside, and we dig deeper into some of the design decisions. But yeah, just to throw it out there that I have had everything up to CEOs come along to the course and get, well, they've told me they've got significant value out of it.
Awesome, awesome. Well, I guess, yeah, that's enough for us. We're just looking forward to see you in person